Welcome to the session on Introduction to Machine Learning. I'm Suganya. Now we are going to see the basic concepts and applications of machine learning. Here, first we are moving on with what is machine learning. Machine learning, we call it as ML. It is a subset of artificial intelligence, that is AI. It is commonly called as AI, that enables system to learn and we can able to improve from experience without being explicitly programmed. So there is a conversation between a human and a machine. The human is saying, I can learn everything automatically from experience. Can you learn? So the human is asking to the machine. The machine is replying that, yes, I can also learn from past data with the help of machine learning. This is what the machine will reply. So the machine will tell you that it is learning from the data which has already been there. So the data which has been already trained, it has been presented over and it has been recorded over in the machine learning. Next, we are moving on to the evaluation of machine learning. It is started in 1805 till 2017. From 1805, first thing it has been coined over with linear regression, where next in 1957 it is perceptron, and 1959 it is reinforcement learning, and by 1964 it is support vector machines, and in 1986 it is backpropagation for neural networks, and by 1990 it is boosting algorithms, and by 1995 it is random forest. By 1997 it is RNN and LSTM, that is long short-term method. Next, by 2012 it is deep convolutional neural networks. By 2014 it is generative adversarial network. By 2017 it is transformer networks. This is the evaluation from 1805 to 2017 with various variations. So the next one is about basics of ML, that is machine learning. So first, the machine learning, before it has been in the name of artificial intelligence. Okay, so this artificial intelligence, the program that can sense, reason, and even act, and also it can be adopted. So this is what it is called as artificial intelligence. And further, it has been scrutinized into our topic called as machine learning, where the algorithm who can perform, improve, as well as it will expose to more than a data and in more over time. It will be exposed to more data in a overall time. Okay, and this machine learning is further being scrutinized into deep learning. That is, it is one of the subset of machine learning, as we know very well about deep learning concept. It is one of the subset of machine learning in which we can able to multi-layer a neural network, and we can able to learn from the past vast amount of data. Okay, so this is about the scrutinization of artificial intelligence, and then the machine learning, and then the deep learning. This deep learning is further being scrutinized into the concept of data science. The data science here, it is on among the programming concept is the, and then it is used with the domain knowledge and with the mathematical and statistical problems. We are sorting out the data science. This is about the basis of machine learning. First with artificial intelligence, another one is machine learning, another it has been scrutinized into, again it has been scrutinized into deep learning, other it has been again scrutinized into data science, that is with the programming, domain knowledge, and then the mathematical statistics. Next one, how does machine learning works? How a machine learning works, and it is just inputting the data. It is just inputting the past data, whichever already it is collected over. And that data is being inputted over for training. This training which helps you to move around with machine learning algorithms. The training is given over with machine learning algorithms, and we can able to learn from the data. Okay, so while training some of the data with the help of machine learning algorithm, it is very easy to learn from the data. And it has been moving on to the building logical models. building some logical models with the help of machine learning algorithms, where we are able to train the data and we can able to learn from the data. From that, it has been building with the logical models. And if wanted, we can insert some of the new data according to the logical models. And finally, it move on to the output. This is the basic working flow of machine learning. Next one is, there are 3 stages of machine learning is there. First one, it is artificial narrow intelligence, that is called as ANI. ANI is the first stage in machine learning. In that, where we can able to specialize in one area and solve in one problem. We can able to specialize over in one area and we can able to solve that problem in that area itself. That is called as artificial narrow intelligence. It is moving on with the narrowest way. That is stage 1, ANI. Next, it is moving on to AGI, that is artificial general intelligence. This is the stage 2, where the machine intelligence will work. And it also refers to a computer that it is as smart as a human across the board. So it is very, very smarter than the human being. So the artificial general intelligence, that is we called as AGI, it is very common and it has been very helpful. It is also a machine intelligence and it is very smarter than the human being. Well, next we are moving on to the artificial superintelligence, that is called as ASI. So this is the third stage where machine consciousness is there. So machine has been very conscious over. Here, an intellect that is much smarter than the best human brains in practically ever field. So it is very common over. So it is very intelligent over than a human. So it will act like a human brain in more smarter way. So it is very much smarter than the human brain. These are the 3 stages of machine learning. Next one is about comparison of AI and then the ML, that is artificial intelligence, and then the machine learning. So what is it? What is artificial intelligence and what is machine learning? Artificial intelligence is broad term for machine-based application that mimic human intelligence. Not all AI solutions are ML. First we have to notice on with all the AI solutions are not ML at all. But it will mimic like human intelligence. As AI will mimic like a human intelligence. It acts like a human intelligence. Whereas coming to machine learning is an artificial intelligence methodology where all the machine learning solutions are AI solutions. That is very important. Well, next it is best suited for first one about artificial intelligences. AI is best suited for compelling a complex human task with efficiency, with broad efficiency. And it has been best suited for machine learning is it can identify the patterns. Not only that, it is very easy to identify with a large set of data, and it can easily solve the problems in a specific problems too. This is about the machine learning. So best suited for AI is human task with efficiency, and here in machine learning it is best suited for solve specific problems. Well, coming to the methods, AI may use a wide range of methods like rule-based neural networks, computer visions, and it goes on with that. So artificial intelligence will be widely using over the methods, and which has been helpful for scrutinizing the data also. And here, while coming to the machine learning, we have some people where we can able to manually select and even we can able to extract the features from the raw data. So, and we can able to easily assign the weights to train the model. This is about the work of best method works of machine learning. Well, coming to the implementation, all implementation which has been depending upon the task and even the AI is often pre-built and assist via API. So AI is always been implementing over and it has been depending upon the task also. Whereas when you're coming to machine learning, you can train the new or existing machine learning. So already it is there means we can able to train. If the existing machine learning is there means we can able to use the machine learning models and for specific use cases and we can able to build the ML APIs that have been available. This is about the comparison of AI and ML. Well, coming to the next one is about classification of machine learning. The machine learning is being classified into three major parts, that is supervised learning, unsupervised learning, and reinforcement learning. These are the major classifications of machine learning concept. Next one is about the further classification of machine learning. The machine learning can be further classified into, first already I have informed you about supervised learning, unsupervised learning, and reinforcement learning. This supervised learning is further classified into two. One is classification, another one is regression. So coming to the classification, there are some algorithms which follows over in classification. First one is Navy Bayes classifier. Second is decision tree. Third one is support vector machines. Next one is random forest. And then K nearest neighbor. These are the algorithms which has been following through in classification under the supervised learning. Well, coming to the regression, we have linear regression, neural network regression, support vector regression, decision tree regression, lasso regression, ridge regression. These are all the algorithms which comes under the concept of regression in supervised learning. Next, we are moving on to the unsupervised learning. It has been further classified into clustering, where we have k-means clustering, mean shift clustering, DB scan clustering, agglomerative hierarchical clustering, Gaussian mixture. These are the algorithms which follows over in the concept of clustering in unsupervised learning. Next, we are moving on to the reinforcement learning, where it is further classified into decision making, where we have three main decision makings are there. One is Q learning, another one is R learning, another one is TD learning. These are the three main learnings algorithms that are being under decision making in reinforcement learning. Next, we are moving on to the concept of supervised learning. In supervised learning, the model has been trained according to the labeled data, and even it is meant to correct the output which has been known. And it is also commonly used for classification and regression tasks that we have already shown in the previous slide. So here is an example where the input data are there with some annotation. The input data that is given over, for an example, I have given a figure of apple. So these are the apples with an annotation. When we are inputting some of the data with a figure of apple as well as a banana, There we can able to apply a model, and finally we can able to predict. Since we already know the inputted data of apple, it is easy to predict that from apple with banana. So this is the concept of supervised learning. So with banana and then the apple. Apple is already been inputted, it has been trained. So it is very easy to find out the figure of apple, and finally we can explicit the figure of banana. So this is the concept. It is easy to predict which is called apple. This is the concept of supervised learning. Next one is about unsupervised learning. In this unsupervised learning, the learning which deals with the unlabeled data. It is not like supervised learning. It will even modelize and it will identify the patterns, and even it will structurize the data. Not only that, it is used for clustering and association. So the unsupervised learning is a type of machine learning where the algorithm will learn from the unlabeled data. Since in supervised learning, the apple is an input data where it is learned, whereas here it is unlearned. The label which is not yet been, the data which has not yet been labeled. In any predefined outputs or targeting variables, we can use it. So here is a raw data, raw inputting data, which has not been labeled. It is an unlabeled data. That data is moving under the database town where the three major processes been going on. One is interpretation, the second one is algorithm, third one is processing. These three things are under the database town. And finally, it move on to the output, the interpretation, and then it applies over with algorithm and it will process, and finally it move on to the outputs. In this unlabeled data, you can find one as onions, second one is brinjal, and then the last one is capsicum with green and red. Even though it is colored with green and red, it can be classified over as capsicum. So here in the output, we can clearly notify that the vegetables that are being listed over in inputting the raw data with unlabeled data that are being classified into according to it. So capsicum, brinjal, and then the onions are being listed here. Next, we are moving under the reinforcement learning in machine learning. So reinforcement learning is all about the training the agent, and it will make a sequence for the decision by rewarding with the correct action and penalizing the wrong ones. Not only that, it is used in robotics and in gamings. Here are some of the raw data which has been clustered over. There we can find out some of the shapes like star, square, and it goes on with. The star is being further, it is in two colors. Here, this is the input of raw data. This data is again move on with the environment. This environment has some process like the environment which move on with agent and then again to the environment. In between, we are finding out the output. With this environment is being rewarded and it is being stated. The stating which comes under with any of the selection of algorithm, and it finally move on with the best action. After that, it is being classified over with the output. with some colored with stars and then squares. This is about the reinforcement learning. If there is any wrong one appears over, it is being penalizing. Next, this machine learning concept can be applied over in various fields. First, it has been applied in automatic language translation, medical diagnosis, stock market trading, online fraud detection, virtual personal assistant. Next one is email spam and malware filtering, self-driving cars, product recommendation, traffic prediction, speech recognition where NLP will come. Next one is image recognition. These are the various fields where machine learning is applied over. And we can even further classify these machine learning concepts in according to the learning models, that is supervised, unsupervised, and then the reinforcement learning too. Yes, the slide is there with you. Supervised learning. The application of supervised learning is spam detection, medical diagnosis, fraud detection, and image classification. These applications which comes over under the concept of supervised learning. Next, customer segmentation, market basket analysis, anomaly detection, data compression. These are all the 4 things which comes under the unsupervised learning. Next one is reinforcement learning. In this, self-driving cars, robotics, game AI, recommendation system, all these applications which comes under reinforcement learning. Next, the major concept that we are coming under is data in machine learning. What do you mean by data? Data, it's a raw fact. Data, it is a raw fact. Collection of data is coming under information, or processing of data which comes under information. So here, data is one of the backbone of machine learning model, and we can have a large or else high quality and even a diverse data set, which have been very essential for training an accurate and generalizable model too. So data has been a backbone of machine learning. We have 2 types of data here, where one is labeled data, another one is unlabeled data. As I said earlier, we have the data which has been processed into an information and finally it converts to a knowledge. That has been figured over here. So here there is a 2 classification, since I said earlier about labeled and unlabeled data. The labeled data includes the concept of label, and also it will target the variable. Even it has to model by trying to predict. Whereas coming to the unlabeled data, the data which does not include any of the label, and even it will target to a variable. This is about the labeled data and unlabeled data. Next one is, how do we split data in machine learning? The machine learning, the data has been split in 3 various things. One is training data, validation data, and testing data. There is 3 different forms of data are here. One is to train the data. After the training, we are moving on to the validation, and finally it is under testing. This is the data in machine learning. There are different forms of data that are available over in machine learning. One is numeric data, second one is categorical data, and third finally it is ordinal data. Coming to the numeric data, where the information or data that is something which is measurable, and it is always to be collected in number forms. And even though there is other type of data that are also been appeared over in number forms too. This is called as a numeric data. Next, we have categorical data. In this type of data, we can able to store it into a group. We can able to categorize into a group, and with aided names and labels, it has been categorized. How a supervised learning, the input data has been categorized and figured as apple. It's the best example I can give you now. Next one is ordinal data, a type of qualitative, that is non-numeric data. It is one of the qualitative, but it is non-numeric, and that is being grouped in a variable into a descriptive categories. This is about the different forms of data. Next one is about training and testing data. These are the two typical divisions over in data. One is training data, another one is testing data. The data set is typically, as I said earlier, it is divided into two. One is training data, which is being used to train the model. Next one is testing data, which is being used to evaluate the model and its performance. Even it is further set as overfitting and underfitting. Overfitting occurs when the model performs well on training in the data but poor on new data. So it is well in trained data existing and it is very poor in the new data. That is called overfitting. Underfitting occurs when the model fails to capture patterns in the training data. While the data is training, on that time, when it fails to capture the patterns, then it is considered to be a underfitting. Next one is cross-validation. Cross-validation is one of the technique which is used to evaluate and to modelize the performance. It can even be dividing the data into several subsets, and it is being under the concept of training and testing the model in multiple times. Next one is model evaluation metrics. In this, we have a common evaluation metrics which we have accuracy, precision, recall, FN score, and AUC ROC, that is area under the receiver operating characteristics curve. And it has been for classification models. And we have mean square error MSE for regression model. For classification model, we have accuracy, precision, recall, FN score. For regression model, we have MSE. This is about the model evaluation metrics. Next, we are having some challenges over in machine learning. The first challenge that we are facing it over is data quality and the availability. The second one is about model interpretability. The third one is about the scalability. And the fourth one is bias and fairness. These are the four challenges that we are facing it over in machine learning. The data quality is more important and the availability of data has been more important. And finally, when you are coming to model, which model to be applicable for in particular to that particular data. And finally, it is to be scalable, and we have a bias and fairness over in the machine learning. These are the major challenges. Next, we are moving forward to tools for machine learning. We have some other tools, some popular tools over for framing the works and which includes over scikit-learn is one of the tool in machine learning for training the data, and then TensorFlow, and then Keras. Finally, it is PyTorch, that is Python Touch. So finally, what is the further future of machine learning? Further, how to move with the machine learning? What is the future? The future of machine learning, which has been in the hands of us, and we holds the promises over in various areas such as personalized medicine, autonomous system, natural language understanding, and more advanced AI. This is the future of machine learning. Well, we can move on with the projects also on these bases. Thank you. If there is any doubt, feel free to ask me.